Here we have the Unit 3 review for the final exam. So Unit 3 was about completing the square to put a function into vertex form. When we complete the square, our goal is to create the situation where our function is written in vertex form, which looks like this. We therefore want to look at the first two terms, common factor out the a value, which in this case is -3, since it's the first term in front of the x squared, and therefore we're left with x plus 2, x squared plus 2x in brackets. And we're going to leave that plus 2 over on the end because that's going to be part of this k value. With the two terms in brackets, we now want to see what will make it a perfect square trinomial. So what number do we need to add in here so that this perfectly factors? So we call that the c value, which is found by doing the middle term b over 2 and then squaring it. So in this case, our c value is 2 over 2, which is 1, all squared, which is 1. So we're going to add in a 1 and subtract a 1 in brackets, not out of the brackets yet. Because the factor of -3 is there in front, we're not really adding 1 and subtracting 1. We're really doing that times -3. So we're going to leave what we want, which is a perfect square trinomial, and we're going to take that -1 out, but it is being multiplied by the -3. So we're going to multiply out +3, two negatives make a positive, plus 2. We're then going to get the -3. This perfectly factors to x plus 1 times itself, so squared, plus we now have a k value of 5. Let's try the second one. Looking only at the first two terms, factor out the a value of 2. We're left with x squared minus 4x. Leave the 1 out of the brackets on the right. With the function in brackets, we have x squared minus 4x, and we need to figure out what will complete it. So we take that -4, we do half of it and square it. So that would be -4 divided by 2 is -2 squared is 4. We're going to add and subtract the 4. The reason we subtract the 4 is because otherwise we would be changing the equation. What we need to do is to manipulate the expression. So we have a 2 being multiplied by a -4. So if I want it out of brackets, I need to multiply it by that 2. So we're multiplying out a -8. We're left with a factor of 2 as our a, x minus 2 squared minus 7. If we go back here, this number was -2 that was being squared. -2 is happening twice in a perfect square trinomial. Let's now review solving. So when we're talking about solving, we're finding x-intercepts or zeros using the quadratic formula. To review the quadratic formula, go back in your notes. Make sure on your study notes you write out the exact formula properly. This will be given to you on the final exam. So we have our a, b, and c values in front of the three terms. So to find our x-intercepts, we do the negative of b, in this case is -1, plus or minus the square root of, we have -1 squared minus 4 times a is 2, c is -3, all over 2 times a. So we have 1 plus or minus the square root of, this is 1. 2 negatives here make it a positive 24. Therefore, we get 25 all over 4. You guys should be using your calculators. 1 plus or minus 5 all over 4. So we get 2 answers. We get that x equals 1 plus 5, which is 6 over 4. And we get that x equals 1 minus 5, -4 over 4. So our two answers are 3 over 2 and -1. Here we'll just use the variable t. Same idea. The negative of -b, I'm going to skip steps, is 8. Let me write that a little nicer. t equals 8 plus or minus the square root of negative 8 squared is 64 minus 4 times 3 times negative 12, the 4ac, all over 2a, which in this case is 6. 8 plus or minus the square root of 64 minus, plus 144. 208 all over 6. 208 can be written as the root of 16 times the root of 13, and we're all over 6. Therefore, we have 8 plus or minus 4 root 13 all over 6, and we can divide by 2. 4 plus or minus 2 root 13 divided by 3 is the best simplified form. Our third example has fractions. What we want to do first is multiply all three terms by 6 in order to clear the fractions. Here we end up with 2x squared plus 18 divided by 2, 9x plus 24. And if we multiply 0 by 6, it's still equal to 0. And we can go from there. Negative 9 plus or minus 9 squared is 81. Minus 4 times 2 times positive 24, all over 2a, which is 4. Without going further, I can see that we're going to end up with the negative 9 plus minus the root of a negative number. The negative number does not exist, therefore we write no solution. And we can stop solving from that point forward. We are now reviewing the discriminant. The discriminant, we use the letter capital D, is represented by what is under the square root in the formula. This is a shortcut for telling us if the equation has solutions, what number of solutions they have, and the type. Are they imaginary? Are they real? Are they equal? So if we just look at the b squared minus 4ac, we can save ourselves time in case there is an equation that does not solve. We end up here with 49 plus 15 times 8, which is 120. When we add that together, we get 169. This can be square rooted. Therefore, we will get two real, distinct roots. Please review this lesson in Unit 3 if you are having trouble. The discriminant here, negative 5 squared, b squared minus 4 times a times c. We have 25 minus 32, and we will get negative 7. Therefore, we have two imaginary roots. Here, graphically, we would have had two x-intercepts. Here, we would have no x-intercepts, as we saw in the previous example. Our discriminant in C will be 16 squared minus 4 times 2 times 32, which ends up as 0. We therefore have two real equal roots. In this case, on a graph, we would have one x-intercept. This is the situation where that square root from before here would come out to be 0, and we would not have a plus or a minus option. Therefore, we would get one solution. Oops. Okay. Question 4. We have a function, and we are going to review factoring in order to graph. To factor this function, we had an equation like this on the test, an example like this, common factor out of 2, and we end up with x squared plus 6x plus 8. And we can factor that to x plus 2, x plus 4, two factors that add to 6 and multiply to 8. I'm going to skip the y-intercept for a minute and go to the x-intercepts. The x-intercepts here are negative 2 and negative 4. They are the numbers that make these brackets 0. I can graph them here on the grid. We therefore know that the line of symmetry is at -3, x equals -3, which is halfway between. In order to find the line of symmetry, you do the two x-intercepts. Fix that. 2 x-intercepts divided by 2, and we get -3. And we can therefore find the vertex by subbing in x equals -3 into the equation. The equation was 2 times. We'll plug in -3 plus 2. Yep. And -3 plus 4. We end up with 2 times -1 times 1, which is -2. Our vertex is at -3, -2. If I go back up to the graph, and I go down to -2 on the axis of symmetry, I can draw my parabola just like this. Hopefully you draw it nicer than me. And the y-intercept here is always in standard form the c value. It's when x equals 0. In this case, y is 16. You can see that if we were to keep going, it would be around there. We'll do another video for Unit 4.